All right, let's go ahead and get started. We're going to give you about 5 minutes for you to complete this problem. So take about 5 minutes, pause the video, and in 5 minutes or whenever you see that everyone is pretty much done, come back so we can explain. So at this point, go ahead and pause the video. All right, so let's go ahead and check our answers. So Carlos bought a new car for $55,000. All right, so let's go ahead and highlight that as an important information. We know that the car decreases by 13.8%. Remember from last class, cars depreciate, which means they lose value over time. All right, so el carro cuesta 50,000 y baja de precio 13.8% al año. We want to know how much will the car be in 5 years. So, ¿cuánto va a costar el carro en 5 años y medio? So, 5.5 years. So, because we're losing value, we're going to be using the decay formula. Estamos perdiendo valor, so vamos a usar la fórmula para reducir. All right. So, once we know the formula, let's just go ahead and input the numbers that we need to input. So we know A represents, so we know we need to find A, the R, and the X value. So this is going to be Y equals A, which is our initial value. And in this case, that is $55,000. So that is $55,000. 1 minus, because it's losing value over time per year. And we know that that's going to be the rate, which is 13.8%. Now, remember, when it comes to the rate, what we want to do is we want to divide that by 100. So divided by 100, which gives us 0.138. So that's going to be our rate. So let's go ahead and input it, 0.138. We're going to close it. And now we need an exponent. The exponent, remember, represents time, which in this case is 5.5 years. So I'm going to go ahead and input 5.5. And now make sure that you're plugging all of that into the calculator. And let's see what we get. So 0.138 to the power of 5.5. And I get about $24,000, $302 with 59 cents, which means that in 5 years, 5.5 years, my car almost lost over half of what it was worth when I bought it. So $24,000. All right, so if you got $24,000, good job. Now let's go ahead and turn into our notes. So go ahead and take out your notes. And we are going to start the last section of this unit, which means we're pretty much done with everything that we needed to do. Next week, we're going to focus on reviewing and taking the test. Cool. All right, so today we're going to go over 6.3 exponential growth and decay. This is going to be part 2. Notice it's missing a T. And now I'm going to introduce you to 2 concepts. We know that there's an exponential growth and that there's an exponential decay. We got growth and we have decay, which means one goes up, one goes down. So one goes up, one goes down. And we know the functions, but if you look at the functions, if you look at the equations, they're pretty much the same. So what's going to change? How do I know that an exponential function is growth? And how do I know that the exponential function is decay? Well, there's 2 ways to figure this out. So if we focus on the growth, we want to look at the B value. Okay, nos vamos a fijar en el número B. If the B value is greater than 1, right? So greater than 1. So si nuestro número B es más grande que 1, that means that we have exponential growth. So if the b value is greater than 1, we have exponential growth. Another way to see exponential growth is to see it in an exponential model. So for example, if you see y equals a 1 plus r to the power of x, as soon as you see that plus, that also means that it's growth. All right. So otra forma de ver esta ecuación es usando el modelo. So si tiene un más, significa que también es exponencial para crecer. All right. So again, summary, 2 things. How do I know that it's growth? B has to be greater than 1, or I need to see a plus symbol. All right. Now, how do I know if my function is decay? And if you guys need to pause the video, let me know, or just pause the video, let the sub know. So an exponential function is decay if b is less than 1, such as fraction or decimal. So para saber que la función es va para abajo, el número b tiene que ser menor que 1, o sea, una fracción o un decimal. All right, so again, what's a different way of seeing this? I could look at this function in a model, which is y equals a 1 minus r to the power of x. So I know that it's going to decay if I see the minus or if the b value is less than 1. So en resumen, si ven un menos o si su número b es menor que 1, una fracción o un decimal, mi función es decay, que significa va para abajo. All right, so either you see a minus or you see something that is less than 1. So let's look at the example. And if you guys need to copy that down, make sure that you pause the video. So here's my essential question. How do you identify growth and decay functions? So in my example, I am given a bunch. I am given a list of functions, and my job is to identify if they're growth or decay. What I want you to do is I want you to take 1 minute and 1 minute only, because it should not take you that long. And I want you to identify if they're growth or decay. I want you to just write growth or decay right next to them. So 1 minute, pause the video, we'll come back. All right, let's go ahead and check this out. So to check your answers, first one, notice that there is a minus, which means that this is decay. Number 2, we don't have a model. We can only see the b value. And if you look at the b value, right, if we're comparing the function, this is y equals a times b to the power of x. So we can clearly see that 7 is our b value, and it's greater than 1. 7 es mayor que 1. So this is growth. Esto va para arriba. Same thing for the second one. We can clearly see that our b value is 8/7. Now, if I was to put 8/7 in the calculator, so a divided by 7, it would give me 1.14, which is greater than 1. So 8/7 equivale a 1.114, que es mayor que 1, which means this is growth. Next one, I can clearly see that plus symbol, so that's an easy one. This is also growth. Next one, I am going to write the equation again. So y equals a times b to the power of x, which means that's my v value. So my v value is 1/5. So if I put 1/5 into the calculator, I get about 0.2, which is not greater than 1. So this is exponential decay. 1/5 equivale a 0.2, que es menor que 1. Entonces tenemos una función que baja. And finally, the last one, we have 0.25. So we can clearly see 0.25 is less than 1, which means that this is also a decay function. So hopefully you got most of those correct. All right, so what you're going to be doing right now, you're going to be working on a practice sheet. And this is what the practice sheet is going to look like. Let me go over a few problems so I can explain what it is that you're going to be doing. All right, so I'm going to go over maybe a few. So for example, the first one, and it should be super easy. You might be done a little earlier, which is completely fine. You're going to be working on something else from another class. So if you look at number one, I got my exponential function, and this is in the form of a model, which means I got, oops, not that. Which means I got y equals a times 1 plus r to the power of t. The first question is asking you, does this function represent exponential growth or exponential decay? Well, we see the plus symbol, which means that this is exponential growth. So I'm going to go ahead and just write growth. Now, when it comes to my initial value, which is letter B, what is your initial value? Remember, your initial value is the A value, which we can clearly see that is 1,200. And finally, this is the tricky part. What is the rate of growth or rate of decay? This could get really confusing. In this case, it's really easy because the rate is that one right there. So it's 0.3. Now that was really easy, right? Well, what if we have a problem like number 3? So if you notice number 3, my exponential is just in exponential form, which is a times b to the power of t. Well, let's go ahead and answer the questions that we can. Does this function represent exponential growth or decay? Well, we can clearly see that that's larger than 1, which means we have growth. We can clearly see for letter B, what is our initial value? We can clearly see that A is 100, so we know that it's 100. But now, how do we figure out the exponential rate? Notice that I don't have an R per se. So how did you find it? What you're going to be doing is very simple. You're going to take 1.25 and you're going to minus 1. Which we get 0.25. And I'm actually going to be writing this over there because that's where it's supposed to be. So there you go. My rate is 0.25. And that's how you're going to be finding the rate when it's not completely given to you. All right, good luck. Make sure that you write your name on it. We will collect this at the end, so make sure that you do it. And I'll see you on Monday.